Hi. So just now we went through the architecture diagram of my data platform. Now I'm going to walk you through the how the code is organized, what each part does. What you see over here is my GitHub repo, and this is the root of the repo. There are main five folders over here: modules, environments, Docker, ETL job, DAGs, Kubernetes, and scripts. So I'm going to explain each module in more detail. For now, this modules folder is where the core Terraform code lives. It has multiple folders inside it. Each folder is for one AWS service. So this this module creates Airflow in AWS. Then this creates ECR, EKS, IAM roles, monitoring. Here we create CloudWatch dashboards, and so and so. Then on the environment part, here I have defined three folders. This is for development, this is for staging, and this is for production. Then DAGs over here, we have our Airflow pipeline code. Then Docker ETL job. This is where our ETL job, the Python script lives, and Docker file is used in which we create a container image of this one and run it on Kubernetes. In this module, Kubernetes, it has multiple configurations inside it, which we apply after cluster is getting created. It has to do with the IRSA role and some other configurations. Let's go more detail into each one of them. If we look into these modules and then networking, and within that, within each module you will see the same folder structure. There is a main.tf file, variable.tf file, output.tf file, locals.tf file, data.tf file. So that's the common structure everywhere. If we look into the main.tf file, so this is the code I have written. What it creates a AWS VPC, then internet gateway inside it, then three public subnets, three private subnets, depending on the availability zone. As you can see over here, availability zones will be 3, that's why 3 will be created. Then there will be elastic IP for NAT gateways, because whatever the components resources are there in the private subnet, they need to communicate with internet, so they will call to the NAT gateway, and via that they will communicate to internet gateway, and so and so. Looking further, I do have created the route table. So then there is route table association. For monitoring the VPC, I have created the VPC flow logs also. These are some policies to be associated. Here I have created one S3 VPC endpoint, because the private resources within the private subnet, they need to communicate to S3 bucket, so the data transfer should not happen over internet, it should happen within the VPC. So I created one S3 VPC endpoint for the same. That's about our networking module. Then looking into the IAM roles modules, going to main.tf. So first role I created is for EKS cluster, and the naming convention is same, like my project name is data platform, then var.environment becomes dev, then EKS cluster, and there is a policy to be associated with that role. Then I have created a node group role. This role will be associated with each node in the cluster. I have followed some particular tag structure over here. Each worker node should have a particular policy to be associated with it, so that has been assigned. This this is one of the important addition done over here. What I have done, the pods which run on the worker node, they need to connect to the S3 bucket, and for that connection I have added this policy, so that the bucket, there is some extra block about the same at the bottom. I will explain in detail. Okay, so there is this Airflow execution role which has relevant permissions to call STS, AWS STS service. It will be named as data platform -dev -airflow. Then this role should have relevant permission to access the S3 buckets. So I have attached one custom policy named as MWAA over here. This reads, because there are two buckets, DAG bucket and the data lake bucket also. So both should be accessible by this MWAA role. The same role MWAA, it also needs to publish the logs to CloudWatch. So this is the third permission given. Similarly, it needs to publish metrics to the CloudWatch, so extra permission is given. The same role also needs to send the task details to the SQS, and then this task will be captured by the worker nodes and run further. So this is the policy for that one. Permission for the same. Encryption details, getting the secret, because the Airflow needs to access the EKS cluster. So the kubeconfig has been stored at the secret manager service in AWS. That's over here. This is one of the important role which we use at the very start. It's GitHub Actions OIDC role. In the architectural diagram, I showed you that, for example, over here, GitHub Actions, we have push, play, apply options over here. How does this communicate with the AWS over here? So the GitHub Actions IAM rule has access to particular token associated with the AWS infrastructure, and that token lives for 2 hours. Within these 2 hours window, the IAM role has access to various AWS services, and it can do the deployment as required. Relevant policy have been added to the role. That's about this IAM role. Going one step back to see the next role, and it is EKS. Sorry, it's a new model, EKS. So using this, we create a EKS cluster. Authentication is using API and config map. So it allows the cluster should allow access. This is the cluster. It should allow access by the Airflow execution role. That's why we configured this API and config map level authentication mode over here. I have configured 2 node groups, primary and secondary. Then there are some add-ons to the EKS configured, like VPCNI, Core DNS, Kube proxy. I have created one resource named as EKS access entry. So that is being created over here, and it allows the Airflow IAM role to communicate with it to access the relevant permissions over here. As I mentioned about add-ons, it's over here. This TLS certificate, so, and this part, these 2 parts are about the pod which are going to run inside EKS. They need to connect, they get particular credentials. That's about the EKS model. Let's go one more step back and moving to Airflow module, main.tf file. I have created 2 buckets, as I mentioned. S3 bucket for DAGs, and it has versioning enabled, Then I have blocked all the public access over here. And then there is another bucket. There is folder inside it called as DAGs. This is for security group to be associated with the Airflow environment. All traffic allowed. And here I am creating the Airflow environment. Version is 3.0.6. That's about Airflow. Move to S3 data lake. So there is S3 bucket which has two folders, raw and processed. So the raw folder contains the raw files of different format, and this S3 bucket is mainly for the storing the data in the raw format or in the after transformation in the process format. So one bucket is created, and the naming convention, as you can see, or is project name, then dev data lake, and there is one account ID also added next to it because we wanted unique buckets across all AWS accounts. So that has been created. Encryption enabled. Again, block all public access to the S3 bucket. Yeah, this is one of the important things which I added is about lifecycle rules, like how long the whole data will remain in the raw folder. Sometimes when it's 90 days, then it will be of class standard IA. 180 days, it will move to glacier, and after that, it will be deleted. After 365 days, I am deleting the same. It gets automatically deleted. So this sort of data transfer helps in cost saving. There is a little policy also attached over here. Let me go one step back. There is ECR. I created one ECR repository with name data platform, then dash dev etl job. For production, it will be different. Okay. It keeps only last 10 images as it's a development, so I kept the count as less over here. As you can see in the architecture diagram, this is Airflow, which is responsible running the task, but it has to run the task on EKS cluster over here, right, on the nodes. So basically the scheduler in this Airflow schedules the task from the DAG to the SQS queue, and then worker nodes pull that one over here. So the Kubernetes pod operator comes into picture over here to pull the task on the worker node. But how the worker node will run it? The worker node grabs one image from the ECR over here. That's why I configured the ECR. Now moving back. Yeah, that's about ECR. Then secrets. So the kubeconfig configuration file for Kubernetes has been stored in the AWS secret manager. It has been used by the Airflow IAM role to access Kubernetes. And at last, it's a monitoring. So I have created a CloudWatch dashboard and SNS topic so that matrices logs are getting pushed to CloudWatch dashboard. So there are VPC flow logs which gets pushed to CloudWatch dashboard. Metrics from Kubernetes and also from Airflow gets pushed to CloudWatch. Then also alarms are being sent to AWS topic, and from there it can get forwarded to particular email ID. Okay, because SNS also has an email subscription over here. So then looking into AWS CloudWatch dashboard, here you can see the metrics which I have configured: EKS CPU utilization, can be visualized. Then MWAA scheduler heartbeat, okay, Airflow scheduler heartbeat is configured, matrices about DAGs bucket not accessible, then data lake bucket not accessible. There could be more matrices can be configured like EKS RAM utilization, timed out error, y-axis error. I will do the same in future. That's about the module section. Now I would like to move to the environment section. So if you look into the environment sections, there are three subfolders: dev, staging, and prod. The classification is done to isolate the infrastructure for development mode, also for staging mode and production. If let's refer the development over here, and there is a Terraform tf-vars file where we configure all the variable values, like what would be CIDR, availability zones. So this tf-vars files values are being passed to variables.tf, then they are getting called inside the main.tf file. You can see here this main.tf file calls each module which we saw earlier: networking module, then IAM roles module, then SC data lake, EKS module, and also this you can see some variables have been configured, like cluster version is equal to how much. So it calls to variables.tf. One second. So let's take an example of this one, module EKS, which is going to be the cluster version. So here it calls to variables.tf file. If we go one step back, and in variables.tf file we have cluster version, but the default is 1.29. This value can be overridden using the Terraform tf-var values. Here I have configured 1.32. So the flow of variables comes from mainly from terraform.tf-vars to the variables.tf, and then it goes to the main.tf. Then from here it is being passed to each module. So within each module also there is variables.tf value. You can see all those values or modules we discussed, they have been configured over here. This is one of the IAM role which I configured separately. It's because of it has to be referred to the service account for the pod. So let's say the pod is running on the EKS worker node, and it is supposed to call to S3 bucket, and in that case the pod should have access to the service account. That's why I have configured it over here, because if I configured in IAM roles modules, that module was dependent on EKS module, and EKS module is also dependent on IAM roles module. So it would have given error while creating this IAM role. So it made sense to keep this IAM role separate at root level rather than putting it into the normal IAM roles module, because they both are dependent on one another and this role cannot sit over here. So there is something called a circular dependency, hence I moved this role outside. So what does this role do? It is about the IRSA to be associated with the service account of the pod, and that role has permissions to access S3 buckets and write down the results over there. Yeah. Now I would like to move to, after we are done with the environment section, I would like to go to the next part, that is GitHub Actions workflow. So here you see the Terraform YAML file, right? So this file decides how, when the deployment of the resources happens on Kubernetes. So for example, here I have shared there are three parts, like again plan, apply, destroy, Terraform planning, Terraform apply, and Terraform destroy. On pull request, any pull request that has been done to the main branch of this repo, it can trigger init and then validate the code is right or not, and then do the planning, and also writes this plan in the comment of the PR. Okay, if I do any push, directly push to the main branch, then Terraform apply command comes into picture and the resources start getting created on AWS. So there are two jobs for this. So first is a planning job. Here the event is, if there is a pull request on the main branch, then get access to AWS and then just run this command Terraform init, Terraform check the format of the code, Terraform validate the code, and Terraform plan, and we'll print out the plan in TF plan. Okay, and if in case there is any push to the main branch, especially the main branch, then Terraform apply command will work. So code will be checked out, access AWS credentials, then set up the Terraform, init, and then apply. That's it. I have kept the third job as separate, destroy. So it also works in the same way, init and destroy. If you want to destroy the infrastructure. That's about the GitHub Actions Terraform.yaml file. Now moving to the DAG code which I have. So this DAG code has Airflow pipeline. At the top over here, I'm accessing the AWS account ID, and this has been used to configure the ECR image URL and also S3 bucket name using, because here I have to get these details of account ID and then also form what is going to the ECR image URL and data lake S3 bucket data lake name. Then there is a custom operator fetches EKS connection file from secret manager before running. The custom operator fetches EKS connection file from secret manager before running the task. That way the file is always fresh and always on the right worker machine. Then this task submits a pod to EKS. Okay, and then it runs ETL Docker image. The pod is a specific service account which we discussed earlier, that IRSA, and it gets the AWS credentials and does the further work for the same. Now that's about this DAG. I want to move to the one of the next folder over here is Docker ETL job. You can see there are two files, main.py. This is our Python code about data processing, extract, transform, load the data, blah 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 blah. So this is the actual Python code which a data engineer writes, and it needs to run on EKS. So that's where we need to create a Docker image of the same, and that's where I have configured Docker file. Moving to Kubernetes. And so when the cluster is getting created, this YAML file is the configuration which creates the one particular namespace named as Airflow. It creates a role and role binding. So as I mentioned earlier, there is a one particular EKS access entry gets created over here. That access entry needs to assign to this MWAA execution IAM role, and it also creates a role binding for that role named as MWAA user, and this MWAA user as well as permissions to be attached to the service account. So that's all. This is all the infrastructure in the code, and it can handle all the things on its own. Nothing is hard coded over here. And I have written all the descriptions for this code over here. Cloud, AWS, what is going to be EKS version, storage, what rules I am creating, what is going to be the folder structure, blah blah blah. That's it. Thank you.